Hi Pre-Calc. Just going to help you with a little bit more graphing. So let's try this one. Now this is a cubed function. So cube functions, they look like half a parabola up, half a parabola down, like this. That's the shape. Now since there's a +1 inside the house, inside the function, that means it's going to go to the left. Remember, the rule is inside the function, positive is actually to the left. So instead of that being at the center of the graph, it's actually at the left, 1 unit to the left. So the center of this, instead of it being at the origin, is over here 1 unit to the left. So all you have to do at this point is just get a little more, a point up here to the right and a point to the left, and just draw it. So if I find the y-intercept, right, if I find the y-intercept here and I let x equal to 0, I'll get the point 0, 1. And I'm also going to do a point over here. So you could see, you could either plug in -2, or you can sort of see that if this point is 1 over, 1 up, then the other one's going to be 1 over, 1 down. If you sort of look at the symmetry on this. Okay, so this is going to be half a parabola up, half a parabola down, like that. And then that's good enough for that shape. Okay, let me see what else I have here for you guys. All right, now this guy, you remember who this is? We started the lecture with this. This is your step function, your stairs. Let's see how this is moved. Now there's nothing inside the stairs, which means it's not pushed left or right. There's nothing in the house. So it's not pushed left or right, which means that it's in the center, but, oh sorry, sometimes it does that. But it is pushed up 1. So the very first step is in the center, but pushed up 1. So you always want to sort of figure out where your center is, and then go from there. All right, so it's not left or right. The initial step is not, because the initial step would have been right here. See, the initial step is not pushed left or right, but it is pushed up 1 unit, so it's going to sit right here. All right, this one is more difficult than the ones I did before because you're multiplying it by 2, which means that whatever comes out of here is 2 times larger, right? So if a 1 comes out, it's actually a 2, which is going to add to the 1 to make a 3. If a 2 comes out of here, it's a 4, which is going to actually make a 5. So basically what this means is that it's jumping by 2s. So the next step is going to actually be at 3, because if it's at 1 and it jumps up 2 units, that's going to put it at 3. And the next step is going to jump up 2 units. It's going to put it at 5. Okay, and I'm just going to go do one down this way. So down 2 units, 1, 2 would put me here. It's a little hard with the camera to see the steps, so it's, I hope you guys can get the gist of that. The steps should look the same width. Sometimes you just got to roll with it. Okay, let's try another. Now this guy is a parabola. That's the shape of an x squared. The 3 is not inside the function, it's after the function. And again, nobody's going to write a 0 in here for you. Nobody's going to say like, oh, there's nothing in the house, right? There's nothing in the squaring. Nobody's going to say that for you, that the inside is 0. So if there's nothing in the squaring, it isn't pushed left or right. This guy is just simply pushed up 3 units. So usually it would sit right here at the origin, okay? But it's up 3 units. So the center is right here at 0, 3. And then you just want to scale it. You don't want to sort of like guess. You don't want to just be like, oh, it's here, right? You want to scale this. So maybe put like, plug in a 2 for x. If you plug in a 2 for x, You're going to get out 7. And then if I use that concept of symmetry that we talked about earlier, if this is 2 units away this way, then it has a buddy that's 2 units away this way, which would be at -2, and it's always the same height. The buddies are always at the same height. And then you just got to know that the shape is a parabola. Okay, there's that one. Now this one, this is not pushed left or right or up or down. There's nothing in the house, there's nothing after the house. This 3 is what we were talking about before with the non-rigid transformation. This is a vertical stretch because your C value is greater than 1. So I would suggest you just plug some values in there. You always should know what the shape is of all these functions. This guy's the hook. The only one we're not going to do right now is the this guy here. This guy's pretty challenging. The reciprocal function. We're going to wait. We're going to hit that one up in chapter 2. We will get to it, but we'll spend a lot of time on it. Oh, I'm not graphing over here. I just want to make some values. All right, so what we're going to do is everything that comes out of the radical is going to be 3 times larger, and that's why it's a vertical stretch, right? So if we do 3 times the square root of 0, that's 3 times 0, which is 0. Okay, so that guy's not going to do much for us. All right, if we put in a 1, the square root of 1 is 1, so that's 3 times 1, which is 3. So it would have usually been at a height of 1, but now it's at a height of 3. So now you see where it's stretching. Right, it would usually, the height would be here, but now the height is here because you're multiplying it by 3. So you see it's stretching. 3 times the square root of 4, square root of 4 is 2. This is going to end up being 6. Okay, so like we just said a moment ago, the height would have been at 2. When I plug in 4, I would have been at 2, but we're stretching this. We're multiplying it by, did I put enough marks up? 1, 2, 3, 4, 5. But we're multiplying, so we would have been at a height of 2 here, but we're multiplying by 3, which means we're a height of a 6. So you see, all these points are stretched. They're higher than they would have usually been, which is making the function really stretched up. It should's not the right word. It would have been a lot lower. Its height would have been a lot lower. Right, its height would have been a lot lower, but because of the 3, this is considered a vertical stretch. When you put a multiplier greater than 1 out front, it pulls the heights up. It's stretching the graph. It's lifting it. Woo, we're already after 8 minutes. Did I get at least enough? Okay, I think what I will just do one more thing. I think I'm going to just help you with one of your homework problems that I think is particularly difficult. So I put up the homework. So as you can notice for 1.6, I just want you to evaluate this step function. I did one of those where you plug in the numbers. I did that at the first video. I want you to try to graph these step functions. Okay, so these 2 are step functions. Over here, these are piecewise. Some of these are a bit challenging. I might help you with one of those as a little gift from me to you today. Let's see. And then the other thing for what was the other one we did? 1.7 we did also. So I just want you to do, just in here, I just want you to hit this stack of odds. Just, you know, like this is a parabola, make sure it looks like a horseshoe. This is a cube, make sure it looks like an S. This one's a parabola again, that looks like a horseshoe. That's an absolute value, that's a V. There's a square root, that's a hook with a vertical stretch. There's your step function. I just did one very similar to that. There's a V. There's a parabola. There's another V, and so on. So I'm just giving you this little bit in here. I mean, there's lots of stuff we could do, but I'll just focus you guys on just the drawing. I'll put that on the test, okay? All right, like I said, I think I'm just going to help you out with one of your homework questions. Catch you again soon. Bye-bye.